Hi geometry students, these notes are on the hypotenuse leg theorem. So what we're going to do here in these notes is first of all introduce the theorem, then prove the theorem, and then look at an example of how we can use the theorem in another proof. Okay, so to start, the hypotenuse leg theorem is another way we can prove two triangles are congruent, but it's for a very specific situation. So it says if the hypotenuse and corresponding legs of two right triangles are congruent, then the right triangles are congruent. So the idea here is that if you look at the picture, we have the hypotenuse, which is the side opposite the right angle, and then we have one of the two pairs of legs. So there's a leg here and a leg here, but only one of those pairs are congruent. And we also have the right angles, which we know to be congruent. So now this is technically side-side angle, which we know doesn't work in just any triangle. But the idea here is that it does work, it will work with only right triangles. Okay, so we're going to quickly do a proof here. And to do this proof, we're going to use the same kind of letters we see in these two triangles, except I'm going to move the triangles. I'm going to actually put them together to make one big triangle. So what I'm going to do is off to the side, I'm going to draw triangle ABC exactly in the same orientation. But then what I'm going to do with triangle DEF is I'm going to reflect it down so that the side DF, which is congruent to AC, I'm going to match those up. So I'm going to draw DF on top. So imagine if we reflected this triangle and we flipped it over upside down, then it would look something like this, where D matches with A, F matches with C, this is a right angle, and then this is angle E. And then we also know that side AB corresponds to side DE, which is right here. Okay, so now we're going to use my new diagram to prove that two triangles where you have the hypotenuses, a pair of legs, and that it's a right triangle, that means that those two triangles will always be congruent. So we're going to say statement, reason. And the idea is I can't automatically say use the theorem, right? I can't say, oh, I know they must be congruent because it's a right triangle and I have one pair of legs and the hypotenuse is congruent. I need to show that that works. So I need to prove that these two triangles are congruent by some other way. And what I notice, first of all, is that when I put those two triangles together, they form a bigger isosceles triangle because I have these two sides equal, and that's going to be important here, okay? So first of all, I'm going to write down my givens. My givens are the pairs of congruences and the fact that these are right angles. So I have AB is congruent to DE. I have AC is congruent to DF. And I have that angle C and angle F are right angles. So I'm just kind of abbreviating right angles with RT and then the angle symbol. My reason here is given. So now step 2, I'm going to conclude that I have these that I have a bigger isosceles triangle based on my givens because I have these two sides equal. I know that this is an isosceles triangle. So I have triangle ABE. I could have also called this DBE, right? Because point A and point D are the same. Is isosceles. My reason is going to be, oh, I put a two here. I should have had a 1. My reason is going to be by definition of isosceles. And then step 3 is, well, if the bigger triangle is isosceles, then I know that angle E should be congruent to angle B because if I have two sides congruent, then I know these two bottom angles are congruent. And that's going to allow me to then show the triangles are congruent. So I'm going to say angle B is congruent to angle E. My reason is going to be the isosceles triangle theorem, or you can write if you have two sides congruent, then you know that those two angles are congruent. And then finally, if you now look at how our picture is marked up, you'll see I have an angle, then another angle, then a side. or you could see side, or you could use like this side too. You could do side, angle, angle. But either way, we can now say by AAS or SAA that the two triangles are congruent. And now I've proven the hypotenuse-like theorem, so now moving forward, I don't have to do this proof every time. I can just use the theorem. Okay? What I'd like you guys to do next is actually pause the video and try to fill in the blanks of this proof on your own, then for the example proof down here, and then once you're done, you can press play, and then I'm going to go into the solution right now. So pause the video, try it out on your own, then press play to see my solution. Okay. So in this problem, we're given that BC is perpendicular to AC. So BC, AC, that means that's going to form a right angle. BD is perpendicular to AD. That's going to form a right angle. And then we have AC is congruent to AD. So I can already see we're going to be able to use the hypotenuse-like theorem here. But first, let's write down our givens. So I'm just restating everything above. BC is perpendicular to AC. BD is perpendicular to AD. AC is congruent to AD. Okay, those are my givens. So now we have to formally, because of these two segments being perpendicular, we now know we have two right angles. One of them's right there, so we could say angle C and angle D, since those are the only angles there, to kind of save ourselves some time. So angle C is right and angle D is right. Why? Well, we use the fact that we have these perpendicular segments, so we can say by definition of perpendicular. Okay, if I know I'm using the reflexive property yet, we can think about what is congruent to itself. And we can get the idea that we're going to use AB in both pictures. So we have AB is congruent to AB. And then we have triangle ACB is congruent to triangle ADB. What's our reasoning now? Well, we can use the hypotenuse-like theorem. So I'm going to write HL theorem. Okay, now our goal in all of this, I'm sorry the lights just went out, hold on a sec. Our goal in all of this is to show that AB bisects CAD. So we're going to be done if we can say like this angle on top equals this angle on the bottom. And that's what the next thing is saying, right? It says angle CAB is congruent to angle DAB. So how do we know those things are congruent? Well, we just showed the two triangles are congruent, so now we can use CPCTC to show those angles are congruent. Once we have those angles are congruent, now we know that for a fact AB is bisecting the larger angle here. So we can use, that's what we're going to write in our last step. And how do we know it? By the definition of what it means to bisect. So I'm going to write ray AB bisects angle CAD. And that's the end of that proof. Okay? Now I'm going to ask one more thing of you to do in your homework, which is if you flip to the next page, I want you to try to do just the very first proof. Okay? So you're going to try number 1, and that's all. And we will definitely go over number 1 in class next time we see you.